For this experiment, you will need copper nitrate solution and a sample of copper metal to be used as an electrode, lead nitrate solution, and a piece of lead to be used as an electrode, some potassium nitrate solution in a small beaker, and then solutions of an unknown metal dissolved as a nitrate, and then samples of those metals, X and Y. You will also need some strips of filter paper or string, a well plate, the electrodes hooked into the LabQuest Mini interface that is then plugged into the PC through the USB port. The PC runs Logger Pro Experiment 20 Electrochemistry. First, soak the strips of filter paper or string in the potassium nitrate solution. They only need to be in there for a minute. Place about 2 milliliters of the copper nitrate solution into one of the wells in the well plate. Next to it, place a couple of milliliters of the lead nitrate. Place the salt bridge that you've made by immersing the filter paper in potassium nitrate between those two wells. Then connect the copper electrode and the lead electrode to the red and black end, and then put those metals into the wells. The software displays the cell potential. Press collect and keep that number. Pull the electrodes out of their cells, give them a rinse, put them back, and then reproduce that number at least 3 times. If the cell potential displayed on the computer is a negative value, switch the electrodes red for black. Next, take solutions X and solution Y and put them into adjacent well plates in that well plate. What we're going to do next is test copper to X, lead to X, copper to Y, and lead to Y, so that we can have a little matrix of numbers. This will help us identify what the identity of X and Y are. So make a new salt bridge between the wells that contain the copper nitrate and the dissolved X, and then put the electrode X and the electrode copper in their places, and read the new potential from the computer. These numbers will be transcribed into the data table, and you'll be able, from that information, to identify the unknown X and Y metal from the half reactions here, the reduction potentials.